Hello, everyone. Welcome back to SAT Math Question of the Day. This question of the day comes from the educator site of the from the SAT people. And spoiler alert, this question could possibly be on one of the Blue Book math tests. Okay. Oil and gas production in a certain area dropped from 4 million barrels in 2000 to 1.9 million barrels in 2013. Assuming that the oil and gas production decreased at a constant rate, which of the following linear functions best models the production millions of barrels T years after the year 2000? Dropped from, we need a negative slope, don't we? Because if something's going down linearly, we're told that it is a linear decrease. So if it's a linear decrease, we need a slope that's negative. So we knock these out. It started out at 4 when t was 0. So the question is it 19 or is it 21? It went down to, so it went down from 4 to 1.9 over 13 years. So that's the slope. 4 minus 1.9, or actually it's 1.9 minus 4 because it's negative. We already took that into account, divided by 13, so that's the answer. So that's 2.1? 2.1 over 13? Yeah, 2.1 over 13, right? Yeah, because, 2.1 over 13. So that's the answer, which is that one. Right?
No, that's 21/130th.
I know, but if you multiply both top and bottom of this fraction by 10, you get 21 over 130.
Oh.
Yeah, so that's a little bit of a pattern that you have to be aware of. I guess they don't like, I guess you'll have to answer this better than I do, Seth, but I guess it's not traditional to have decimals in a fraction. That's not a cool thing. I mean, I don't know why, but we'll talk about that later. Why mathematicians don't like decimals in a fraction.
I don't want to talk about that at all.
Okay. Well, we'll talk about it later. Well, I'm going to press you on that. Anyway, in terms of doing the problem, it's a linear, they told you it's a linear decrease. So that means it has a constant
What tells
slope.
you it's a linear decrease?
It says right here, decreased at a constant rate. Linear, that means a linear decrease. So you need to know that.
A constant rate means linear.
Yes, exactly. And that's one of the things that the SAT people clearly want you to understand. Yet again, the choices are all linear. They didn't give any exponential or quadratic expression functions.
What if they gave cubic or root or...
Right, yeah, I know. Then you would have immediately...
It's something other than linear.
You would have immediately... You mean in the problem or as one of the answers?
As one of the answers.
Yeah, you would immediately have to toss it out.
Yeah.
Yeah, and it's a decrease, which means the slope must be negative. So you can immediately cross off A and B because they have positive slope.
Yeah.
So this is really a word problem where it's a y equals mx plus b word problem where you have to fit the data, take the data and figure out what the parameters are in the equation y equals mx plus b.
In y equals mx plus b, what's the rate?
The rate is the slope.
What is it?
Slope. The slope.
I said in mx plus b.
Yeah.
What is the rate?
M.
Yes.
Yeah.
Okay.
Slope and rate are interchangeable in most word problems. And b is the initial amount. When t is 0, b is 13. Now, interesting, I don't know why they didn't make a mistake where t would be 2000. Because there's a offset here. You have to take the number of years and subtract it. You have to take the year you're in and subtract it from 2000 to get the t. They could have given an answer with a negative slope, but something about with 2000 or something.
Well, the most direct way of checking the 4 million condition in 2000 is to recognize that T represents the number of years after 2000. The number at the year 2000 is 0 years after 2000.
Right.
So we should check the choices with T equals 0.
Right.
And they all come out to 4.
Yeah.
Which matches the 4 million barrels, they say, in 2 million.
Yep.
2000. Yeah. And of course, they also, they taught the units in this problem are millions of barrels of oil production.
Yep.
Okay.
Which, by the way,
they call this a difficult problem.
Yeah, they are. They consider it a difficult problem. But as you were talking, I realized the faster way to do it. The faster way to do it is first to realize that A and B are no way they're the answers, and then plug the numbers in. Test these. Test. Or change color. Probably the faster way to do this problem is to test. Test f of 0 and f of 13. And just calculate f of 0 and f of 13. F of 0 is easy. It's 4. F of 13, you would just type it in. Boy, they're lucky. They gave it for people. They rewarded people who did it this way because this is the answer. So that would be negative 21 over 130 times 13 plus 4. Talk about patterns. They gave you a gift there. So this is 1/10, and then 1/10 times 21 is 2.1, and that gives you the immediate answer of 1.9. So testing the answer probably would have actually been the fastest way to do this problem. Testing the choice.
They also made it. They gave a pattern where all of the denominators of the fractions are 130.
Right. Yeah. So this question is reeking of patterns that you could take advantage of to do the problem faster, which is important because there are going to be some problems on the test. There always are, where patterns help you do the problem faster. And the more you spot them, the faster you can do these problems. So, Seth, any other thoughts?
No.
Okay, so why don't we go through our questions? Calculator? Well, probably not. I mean, I guess possibly you could use a calculator for this, or possibly you could do a calculator from 4 minus 1.9.
No, don't use a calculator.
1.9 minus 4.
No.
Again,
no calculator.
Well, but don't waste your time using
no calculator.
I had to think twice because there's carrying involved. 4 minus 1.9, you can make a mistake there.
No calculator.
Okay, no calculator. Fine. Okay. Start with a guess. Absolutely. Well, it's not start with the guess, but looking at the answer certainly helps. It's not quite starting with the answers, but it's really more testing the answers. Once you realize the slope is negative, is a great way to do it. We just talked about that. Are there any patterns? So absolutely there are patterns. My God, we talked about that already. How does this differ from a school test?
Well, another reason for looking at the answers first, is that you could could see from the shape of the symbols that all the answers are linear functions of t.
Absolutely, that's right. We just said that. Yeah. So if you're not sure that what this means,
you could just skim over the wording that says linear and see that they're linear.
Yeah. I mean, the small twist here is that people generally don't like things to go down. Hopefully most people are optimistic, or the reality is many people are optimistic. We like things to go up. We like positive slopes. But this is a problem this is a negative slope. This is something that goes down in time. And how does this differ from a school test? If the teacher goes to these, let's get beyond a school test. Just get beyond a school test. Okay, now the most important question, the main idea. What did the committee who made this question want to see whether you know how to do? Certainly recognizing when a function is a linear function, but here it's almost a no-brainer because they only gave you linear function choices. And understanding how to get the slope and the y-intercept, combined with the understanding of what is the interpretation of the slope and the y-intercept.
As I always say, the main idea is translating a linear rate situation from words into a formula.
Yes. Yes, that's what they want you to know how to do. And it's linear. You could almost be assured a question like this will be on every SAT and possibly in the first question, possibly in the first module. So, I guess that's it. So why don't we see how they did it? I'm sure they did not do it much differently from how we did it. Very standard problem. So let's see what they did. Okay, I just have to move us around a little bit. So just excuse us with some housekeeping here. Okay, well, we got the same answer they did. Okay, so what did they say? Choice C is correct. It is assumed that it decreases. It's not as assumed, it's told to you. Therefore, the function f that best models it can be written as a mx plus b, mt plus b. Good, they're defining the variables. That's very good. And they're even defining the units, which is fantastic. Then they calculated the slope since there were 4 million barrels of gas produced. Wait. Oh, I see. And then they did 0 minus 13. Okay, yeah, so they do get a negative sign there. That's right. Yeah, so that if you're careful about how you define the rate of change, which is y2 minus y1 of x2 minus x1, the negative sign comes out on the wash. I cut corners because we knew already the negative sign the slope had to be negative. If you do that, then you don't have to worry too much about being very careful in this problem about doing the math here correctly. You just know the answer's got to be negative. Seth probably doesn't like that approach, right? Yeah. He would rather put the numbers in the way they should be rather than just putting the numbers in and just making sure that slope is negative. Am I right?
Yeah.
Yeah, okay. Choice A and B, okay, and then we don't talk about why the questions are wrong. So, yeah. Okay, pretty standard. Again, they're not showing them idea of looking at the answers ahead of time, which is what most people, or at least I think most people do in practice. They're not modeling or channeling how most people actually do the problem. So
I take it back. It might be useful to use a calculator to subtract 1.9 from 4.0.
That's what I said.
Yeah,
because there's carrying involved. There's carrying involved. Once there's carrying involved, you gotta really watch yourself. Because, right? And then you put a 2 here, and then you go up, and you make sure you did it right. When carrying is involved, like if you're doing 3.7 minus 0.2, okay, fine. Okay, there's no carrying involved. You could just do that. But once carrying is involved, you got to be careful. Did you notice, if you go back to the video, I paused for about 2 seconds because I had to make sure that was right. So that's it, right? We're done.
We're done.
So I'm Joel. I have a PhD in mechanical engineering. My brother Seth has a PhD in math. We try to meet every day to go over an SAT math question. We offer different approaches. We try to delve into what the main idea of the question is, because while we can't know what the specific questions you're going to have, of course we know what they test on. The main idea is always come up again and again and again, so we focus on that. And we focus on different approaches on how to do the problem. I guess yesterday we talked about plotting points. I guess you could use a Desmos calculator to plot 2 points, 0, 4, and 13, 1.9. But then you'd have to read off the slope. That'd be a stupid way of doing it. Anyway, so we offer different approaches on how to do it, and what you should do for practice, of course, is take every Blue Book test you can. We've heard rumors that Blue Book 4 and Blue Book 6 on the math side are most realistic to the actual SAT that's given, so focus on those. And anything you're weak on, go to the digital SAT Con course, because they partner with the SAT, so we expect them to know the topics that are on the SAT. And to brush up on the topics you're not sure about, but also brush up on the topics you are sure about so you can do those faster, so you have more time to do the harder problems, the problems you run into that are more difficult, that require more time. So please dislike our videos. We take all the comments very seriously. And if you have any SAT math questions you'd like us to go over, please email them to us at satmathquestionoftheday@gmail.com. Okay, we're done?
Yeah.
Okay, everyone, have a great day.